Hello, this is Nick Parakatis with a presentation on geometric sequences. Basically, a geometric sequence is a pattern that can be found by multiplying any term by a common ratio. It could be also called a common multiplier. Just like an arithmetic sequence, we can call the first term u1, and we can call the common ratio r. And here's our u1. There are some examples of geometric sequences that you can see right here. Notice the first one has a common multiplier or a common ratio of 2. The first term is 2. The second one has a common ratio of a half, since we always multiply by a half for 0.5 to get the next term. And the last sequence here has a common ratio of -3, because in order to get every term, you multiply the preceding one by -3. Now, just like the arithmetic sequence, we're fortunate to have a formula that helps us find any term of the sequence. The formula is given by u of n is u of 1 r to the n minus 1. Remember, the formula for an arithmetic sequence was, and I'll just open up our pen over here, u of n is u of 1 plus n minus 1d. This was for an arithmetic sequence. The top one here is for a geometric sequence. Here's a little example so we can see the above formula in action. Remember the formula, u of n is u of 1 r to the n minus 1. We'll put that over here. This example tells us that we have a geometric sequence, 6, 2, 2/3, etc. Notice that the first term, we'll write it over here, is 6. And let's answer the first question. This is what's a common ratio. Remember, to find the common ratio in a geometric sequence, we got to take any term and divide it by the previous. So it could be u2 over u1, u3 over u2. And if we find this, we can take the second divided by the first term. So we just have 2 over 6. And if we simplify this, we get a third. For part B, it's asking for the 10th term of the sequence. So we have to use the formula un is u1 r to the n minus 1 that we get in the formula booklet. We want the 10th term. So we want u of 10. Wherever there's an n, we put a 10. U of 1 is just 6, so we can put 6 there. R we found in part A, it's a third. And we have 10 minus 1. We can find this using our graphics calculator. And what we get here is u of 10 is 0.003048. Here's a neat little example. They're giving us that the second term of a geometric sequence is -15. We could write that down. So the second term, u of 2, is -15. And the fifth term, u of 5, is 405. In general, when you get questions on geometric sequences where they're not giving you the first term, but they're giving you the second, the third, the fourth, and another one, the 7th, the 8th, the 9th, usually these questions involve solving a system of equations, which means you might need to divide two equations and solve for what they're asking for. Let's write down what we know. We basically know the equation, which is u of n is u of 1 r to the n minus 1. And let's use this information that we have and write down the equation based on the info that we have. let's see what we have. U of 2 is U of 1 r to the 2 minus 1. So we wrote down the equation for U of 2. What is U of 2? U of 2 is negative 50. Is U of 1 r to the 1. And we'll write the same equation now. Let's put the first one in a little box here, save it. Call it equation 1. Let's write now the same information for U of 5. U of 5 is U of 1 r to the 5 minus 1. U of 5 is negative 405. U of 1 r, 5 minus 1 is 4. Let's put this second equation in a little box here. Call it equation 2. If we divide equation 2 over 1, we have, let's see what we get. Negative 405 is U of 1 r to the 4th. And on the bottom, we have negative 15 is U of 1 r to the 1. If we divide these two equations, notice that the U1s cancel. Let me just erase the negative in front of the 405. It's positive 405. That was a little mistake. Let me erase that over here. See if there's an eraser I could use. Yeah, let's just erase that and erase the negative there. So we have 405 over negative 15 is r to the 4th over r to the 1. And what do we get? 405 over negative 15 is negative 27. R to the 4th over r to the 1 is r to the 3. What number cubed, guys, gives us negative 27? Its r is negative 3. There's our r value. And in order to find the common ratio, we can use this r value in one of the two equations, either 1 or 2. The easier one is obviously equation 1. So we can plug it into R1, into equation 1, and we have negative 15 is U1 times negative 3. So U1 is negative 15 over negative 3. U1 is 5. This is a pretty good question. Easily you can see this question on an IB exam.